Hi, I'm Alan Gill. I'm the new Cloud and IT Managed Services Director here at the DQ Group. First and foremost, I hope everyone is well and is keeping safe in this pandemic. Um, Apologies for the quality of this video. Someone's once said I've got a great face for radio, and they're probably correct. And I'm certainly no ant or deck when it comes to presenting. Thought I'd reach out today. We were, part of the primary role for me within the group is to grow and develop our digital transformation and our cloud services, ably assisted by Chris Baker, who's recently joined as well. We were hoping to do some face-to-face training, but unfortunately, this pandemic has put halt to that, so that's not going to happen, not soon anyhow. However, we thought in the meantime we'd produce 3 or 4 sort of small 15-minute videos giving some online training as to, firstly, as regards the what cloud is, secondly, more to do with the products that we will be offering going forward, and the third one is really more sales orientated on how that we sort of pitch our services and products to our customers. We are happy to do a fourth one, which would be more of a technical deep dive if anyone's interested. At the end of the courses, we will send out just a small little survey, really a quiz, just to see how we get on. And I'll also provide our email addresses as well. So if there's any queries you've got, any questions or anything you didn't understand, feel free to reach out to us and we'll hopefully try and answer them for you. So as I say, keep safe everyone, and looking forward to catching up with you soon. Take care.
So, what is a cloud? So what is cloud computing? I hear you ask. If you had a look on Google, there's many definitions out there for it, but probably the simplest one is just really to say that it's computing capabilities, so something like virtual machines that use processing, storage, and networking, and that can either be in a shared or a dedicated environment of computers and servers and SANs that are held within a data center, rather than the traditional way of doing things where clients owned their own servers and they were based on their own premises. So what is a cloud made up of? Well, the first element is basically the computer power. So basically the servers that these virtual machines are hosted on. So these servers can either be rack mounted, where basically the servers are sort of turned on their side and screwed into the side of a cabinet, or they can be blade servers, which are smaller in size and they sort of slot into a blade chassis. Each one of these servers has multiple CPUs. CPUs are like the brains of the machine, and inside each CPU you have a number of cores. The only analogy I can really think to give you is that cores are a bit like the lanes in a motorway. Obviously, the more lanes you have, the more traffic you can have going through them. So in CPU terms, the more cores you have, the more processing power it has. By being multiple, clearly that gives a degree of redundancy as well. So if a CPU fails, the other one can take the workload. This is also true with the memory. The memory has resilience built into it, and it means you can put a lot more memory into the server. And general rule of thumb is the more memory you have, the faster the server will go. Again, the servers have multiple network cards, and these cards can be used in several ways. They can either sort of segregate the traffic into different ways. They can be combined together to give a bigger pipe, so that again the networking goes faster. But they also provide a degree of resilience. So if a network card fails, another network card can take the workload. And lastly, each server has multiple power supplies. So again, you're protected in case a power supply fails. The next very important element of a cloud is clearly the storage that these virtual machines sit on. So they're disk arrays. They're called SANs. And basically, they are a bunch of disk drives that run at very high speeds and can cope with multiple disk failures without losing any data. They're also very scalable, and they offer very high performance compared to the sort of disk drives that you get in a normal server. These storage units, these SANs, are connected to the servers via some switching, which they're either iSCSI or fiber. In the old days, fiber was the preferable way of doing things. It was a quicker way, But to be brutally honest with you, nowadays iSCSI is probably equal in speed as fibre is. The actual SAN units themselves can have tiered storage. What that means is you can have disk drives in there of different speeds. So fast storage would typically be your SSD disk drives, your medium storage would be SAS disk drives, and your slow storage would be SATA disk drives. The difference between the two, the slower the disk drives, usually the greater capacity. So you'd have all your important stuff like your emails and your databases and your CRM systems running on the fast drives, and any stuff that you just want to archive that you don't access very often, you would put that onto the slower drives. And again, typically there is a price difference between the fast ones and slower ones, so therefore it's better to have what I call data that's not accessed very often on the slower storage. It comes at a cheaper price. The SAN units also have, similar to the servers, they have multiple network cards inside them to give resilient paths. So if a particular network card or a link goes down, the traffic can go another way. But they also have things called storage processors. Again, these are like the brains, and again, they have multiple storage processors. So if a storage processor fails, the other storage processor will take the load. These SANs can also replicate to other SANs. They can encrypt the data both in flight and at rest, and also all the data is segregated. The glue that sort of holds the servers and the SANs together, in essence, is what they call the SAN fabric. But this is really the sort of networking between the server and the SANs. These switches are very high performance switches, and they can either be Ethernet, which is typically like the network cable you'd see going to the back of your computer, or they can be fiber as well. There's usually multiple switches, and they're set up in what they call a mesh configuration, which is the diagram on the bottom right. But in essence, there's no single path failure. So if any one path fails, the traffic can reroute around another path, which basically ensures that there's no downtime. Again, similar to the servers, the network cards can either be grouped together to give a greater bandwidth, or they can be segregated to give multiple paths, and you can sort of offload different functions of your network to different network cards. Again, higher resilience and better performance. The fourth component of any cloud is what they call the virtualization layer. Virtualization is a software technology that's allowed us to convert physical servers to software-based ones, i.e. virtual machines. Traditionally, whenever you used to have an application, you'd usually have one physical server and usually with a physical application sitting on it, maybe something like Microsoft Exchange as an example. The trouble with that, there was a lot of compute resource that was not being utilized. So that server may have only been working at, say, 20% of what it was capable of, and therefore it was a lot of waste of capacity. What virtualization does, it enables us to run multiple virtual servers on one physical server, thus increasing that utilization. In reality, and without getting too technical, it acts basically as a translator between the physical hardware and the virtual machines that sit on top of it. The two main players, though by far the biggest, is VMware, and the other one is Microsoft. So VMware have a product called ESX, which most of the enterprise players and most MSPs would use. To be fair, in the last few years, Microsoft came up with Hyper-V, and it's growing. It's probably not quite as stable as VMware, but certainly, like all things with Microsoft, I'm sure they'll get their act together. There are other people that do provide a virtualization players such as Red Hat obviously provide their own. Oracle also provide their own as well. But as I say, the two main ones are VMware and Microsoft. Lastly, there are some further components that make up a cloud, though I won't go into any real detail on these as it can become quite technical. But in essence, you have top of rack switching. These are the switches that everything else within your rack will connect to. You then have core routers. Core routers, in essence, route the packets of information around our internal network. They're highly resilient, so if one core router fails, the others can reroute the traffic. The only way I can describe it, it's a bit like a postman delivering letters. The reason that the postman knows where to deliver your letter is because you put a house number, your address, and your postcode on the envelope. So that sort of equates to where that piece of information's got to go to. Routers do it in a very similar sort of way, in that packets of information have discrete addresses on, and it helps routers know where to send that data. BGP routers do a very similar job, but they're the external facing bit, part of the network, to the internet. Their job is to basically shove information from one side of the country to another side of the planet if necessary. It depends where, obviously, that data is going. They're also highly resilient. They can act a little bit in the way that a sat nav does, that if a particular link breaks or a data center goes offline, the BGP routers can reroute the traffic another route so that the data does get to its intended place. Lastly, there's the firewalls. The firewalls there are to stop intruders and hackers from getting onto our network. They can do some other clever stuff as well, in the fact that they can spot some malware or viruses before they get into our network. They can also give some URL protection as well, so unwanted websites don't cause us any problems either. And that really are all the components that make up a cloud solution. So, what are the types of clouds that are out there currently, and what is the terminology people use to describe these clouds? To simplify things, I've broken down the types of cloud into three different classes. The first one is public cloud. This would be the likes of Amazon AWS or Microsoft Azure and Google Cloud. Typically, these are multi-tenanted environments where millions of users share the same compute resource all around the world. The way they sell their products, the virtual machines are sold in discrete bundles, so predefined sizes. Usually, these machines are accessed over the internet, though the likes of AWS and Azure both have a direct connect capability as well. They are all pay as you go, so in other words, you pay on a monthly basis for what you actually use. However, you can do reserved instances as well, and that's where you agree to a agreed amount of resource and agreed amount of time frame, and for that pleasure, you get a lower rate. The next class is a private cloud. These would be typically what MSPs and what DQ have, but equally they can be on-premise solutions as well. But usually with most MSPs, they're hosted in data centers. They can be both single tenant, i.e. private cloud, or they can be multi-tenant, where you have multiple clients that are all using the same resource together. However, it's in a secure fashion, and each client is segmented from the other, so they can't see each other's data. This is usually sold on an agreed contract length and price, so typically anywhere between 1 and 3 years. The last one, which is hybrid cloud, is clearly a combination of both. So you get the benefits of both worlds in the fact that within a private cloud, you can sort of guarantee performance levels and SLAs and add other service wraps around, but you also get the benefit from a public cloud where you can scale out and scale up, and it's on demand. So again, you only pay for what you use. So just to put a little bit more perspective on the class of clouds, if you take this model here, starting on the left-hand side, the left-hand side is where what I'd call multi-tenanted infrastructure, and it's run by third parties. So this would be the likes of AWS and Azure. You then move into what I call the private MSP space, which DQ obviously sits in. And this is where you can offer a mixture of a multi-tenanted private cloud and a private cloud for a single client. And then you move along the continuum to the right-hand side, which is moving more to the single-tenanted infrastructure, where you have co-location, which is whereby we take clients' computer equipment and host it in our data centers, but the client owns the hardware. To the far right-hand side of the continuum, where servers and applications are owned by the client just for that one particular client, and they're on premise. When discussing cloud, nearly everything in this world is described as a service. And if you take this technology stack here, at the bottom of the stack is what they call IaaS, i.e. Infrastructure as a Service. This would typically be your virtual machines that have replaced the physical machines. So these would be the virtual hardware, it would be the Windows operating or system or Red Hat, and it would be the applications that most businesses use to run their organization. So it could be their email, it could be their ERP system, it could be their CRM. Further up the stack, you have Platform as a Service, or PaaS. PaaS incorporates the IaaS layer, but it adds additional features to it. So it typically adds things like web servers and databases. So software houses can write their applications to sit on this level and not have to worry about the underlying infrastructure that runs it. Typically, this would be people that use SQL to run applications or data mining, and there's some other examples there that Amazon provide for businesses to run their applications. The next step up is called Software as a Service, or SaaS. This isn't something that we will be delivering ourselves, but typically it is for the likes of people like Salesforce, Office 365, Netflix, Dropbox, Hotmail, any sort of cloud-based application that you've come across will be sitting at that software as a service layer. As I mentioned earlier, public clouds tend to sell virtual machines in discrete sizes. And I've used the example here of small, medium, and large. That's not strictly true. They do have different names to them. But in essence, these particular virtual machines come in a certain size. The advantage to that, it's very easy to sell. You just either pick a small one, a big one, or a large one. The disadvantage of that is that the sizing of these servers is not necessarily accurate to what you're actually trying to achieve. But this would typically be the way that AWS or Microsoft Azure would sell their services. The other way of doing this is what they call resource-based cloud services. And this is in essence where you design your own virtual machine. So you can have as much memory, RAM, or disk, or networking as you desire, and that you can make it fit for purpose rather than having discrete bundles, which may not necessarily be what you want. Typically, you'd find a resource-based cloud in the likes of what we're going to be doing at DQ, and obviously a lot of other MSPs as well. And lastly, what are the business drivers? What is it that makes people look at cloud computing rather than the traditional way of doing things by keeping servers and that on-prem? Well, there's many reasons to do it and many advantages to do it. Particularly, cloud provides great ability for things like business continuity and disaster recovery, because most clouds are replicated between one data center and another. If anything ever happened to the primary data center, the secondary data center could take the workload over within a couple of minutes. You'd never be able to achieve that if your servers were based on-prem. The other good thing about it is lack of resource. Usually in the traditional world, if you had a server and it was running out of disk space, you'd either have to get new disk drives for it or buy a bigger and better server. Great thing with cloud, you can literally add more memory, literally add more CPU and disk space within seconds. So that gives great ability to upscale capacity very quickly, but you can also downscale as well. And if you take the example of something like Glastonbury Festival as an example, for 11 months of the year, their website will be fairly quiet. But the moment the tickets are released for the festival, they need to scale up very, very quickly to deal with the demand of people wanting to buy tickets. Once the madness is over, they can scale back down again. And again, they're only paying for what they need. Other clients move to cloud because they would rather have an OPEX model, so in other words, a monthly recurring charge, rather than getting surprised by a CapEx request every now and again because they've run out of a certain resource. Cloud's also very good for allowing things like upgrades, because the good thing about it, you can snapshot the virtual machine, so it's nice and safe. You can carry out your upgrade. If the upgrade's good, you can turn that machine on. If it fails, you've still got the old machine to go back to. If you try to do that in the physical world, you'd probably end up having to reinstall the server. A lot of people use it for test and dev in UAT environments. So a lot of software houses do that. The coping with uncertainty element, to this sort of era we're living in at the moment with coronavirus, cloud computing has enabled an awful lot of clients and customers out there to be able to carry on working, where clearly if they're locked out their building, they would not be able to do so at the moment. It also helps with regulatory compliance. It's a lot safer to have your servers based in a data center that's highly secure, biometric security measures, security guards 24/7. Helps with ISO, helps with PCI. And lastly, it's also very good for if you've got performance issues. As I've said previously, you can sort of tune up the performance very, very quickly by adding more resource or more servers. And those are the primary classic drivers for driving to the cloud. Well, that's it for this session, and thank you for listening. Hopefully, you found it useful. If you have any further questions, my contact details are there, and so are Chris Baker's. So feel free to reach out to us. Happy to ask, or happy to answer any questions that you may have. And as I say, we'll put out a second session fairly soon. Thank you.